Okay, I think we can start. Hello everyone, welcome to our today's session, and the plan for today is so we will not continue web applications right now. So we have, as I mentioned last time, we have two topics remaining. This is version control and the project management left for us. So it's almost a little bit more than 1 month left in this course. So the plan is that we have two upcoming topics. These are the project management and version control. We take today and most likely also on Friday, and then we have the project management topic, and after that we will move to the final project of the course. So that's about the plan. Also, we will have the second and the last knowledge check next week. Most likely that will be on on Wednesday or on Friday. Let me check. Let it be on maybe on Friday, if that's fine for you, or maybe on Wednesday. Just you can select which date is better for you. Maybe I will just type in the Discord chat 2 dates, and you can just select which one is better. Check. So that will be 12th of May. Or check. Okay, so that's 14th May. So just vote. Yeah, which one is better for you? With thumbs up or thumbs down? Yeah, if it's not all, and then if it's not available for you, and then just vote. Both options are fine for me. Yeah, maybe someone of you will not be able to join on Wednesday or on Friday, and that's why please select the best date. That's about it, and the next one is also about the organization. That's the plan we have, and as you remember, we have one Saturday which should be excluded, and this will be this Saturday. So I mean, we'll have sessions on these 2 Saturdays, but we won't have the session this Saturday because I have COVID vaccination on Saturday, and I won't be able to present this Saturday. But as you remember, we have one Saturday which we can skip from the plan, and this will be this Saturday. So that's about it. I will provide the topics which will be included in the knowledge check. So this week I'll provide all these topics, and yes, then okay, Alexander's typing. Any questions? As usual, you are welcome to ask them. So let's wait until the picture. Yeah, okay, that's fine. 14, that's fine, and then it's like 14. What? Okay, now that may be complicated. Okay, Julia, everything is up to you now. So to select. Okay, it seems that for Julia 14. Okay, then we can select 14. If Olga, for you 14 is not available, then please let me know. Maybe can maybe find the way how to proceed with this. But yeah, if it's fine, then just if it's not fine, just let me know. But otherwise, that's fine. Okay, so that's about the plan, and right now I think we can start. We'll start with Activity 08. I see that almost everyone managed to do it, so that's nice. I've checked almost, maybe I didn't check from Alexandra, but from the others I checked, so then maybe let's go through now. So for those who submitted, that was everything fine. You used different approaches there, but both approaches were fine. So first of all, what should be done there? So as you remember, okay. Let's start. Something is wrong. We'll see. Okay. The task was related to the exception handling, and the idea was to implement the exception test, the testing on the exceptions. So as you remember, the main idea for the exception handling is try catch. If the method does not have this try catch block, then and there is actually the possibility for the exception, which is not runtime exception, then we should use throws definition next to the method. But first of all, we have to create the exception here, exception class, and that basically it doesn't matter if we create the class like outside. Usually it's better to create the classes in the separate files. Again, it depends. If it's just for testing purposes, then you can keep it inside the class, or you are sure that your class will not be used somewhere else, then you can simply keep it inside one file. But in case you want to make your class, your exception class, or just a simple class in this case, it doesn't matter, more reusable, then it's better to define it in the separate file. So first we need to create the exception, and the name of the class is mentioned here. That's the simple calculation exception. So we need to create this exception class. So I'm creating exception class. I can say that, and I'll say it here, that since this is exception, as you remember, all the exception classes should extend or the exception class or one of the subclasses of exception class. Basically, that's throwable class. So we mostly work with the exceptions. So in this case, we'll have the warning. We need to have the serial number. So in this case, I can simply go to the warning message, and this will generate the serial ID. For us, it won't make any significant difference. So let's check what we should add on. So firstly, let's go through these steps. So we should implement basic mathematical operations with integer numbers in range of -10, 10. Input range is checked using assertions. So we will need to use the assertions and check if something is wrong or not. We can, since as you remember regarding the exceptions, but the assertion is the specific way how to handle and check some unexpected behavior in the testing, during the testing process. Because again, as I said, we do not normally use the assertion, we don't enable the assertions in real production system, like if it's, let's say, the application users use mobile phone or that's web application or whatever it is, then in such cases, of course, when user actually uses the application, then assertions are disabled. But if you are the developer who wants to test if the application works correctly without any issues, if everything basically works as expected, then in such cases you may be interested to use such function called assertions. So because basically, again, we have two approaches. Of course, we can yeah, there are similar approaches. Because as I said, we have assertions to test. Also, the option would be to use try catch in such cases, and just to handle exceptions in a way that that you put the text to the log. Yeah. So basically, this is what I demonstrated you once. It's like you run the program. Then you have the logs. Then during the execution of the program, you may have try catches. Then the exceptions handled in the program during the execution of the program, they will be placed to the log, and the log then will be saved in the database. And after that, so maybe time by time, you as the tester or you as the developer, you may check what went wrong, what's currently going wrong. So in such cases, it's basically the approaches of using try catch and assertions may look the same, but the difference is that using try catch, this will always be executed. We cannot just simply press some magic button, any magic button, and just disable try catch. This is not possible because try catch, that's the part of, it's a strict part of program, and if it's Java or another language, because the approach of using try catch in most of the programming languages works in a similar way. And that's why you cannot disable try catch, but regarding the assertions, you can actually skip them using the parameter in when you run the program. Alright, let's move on. So that's using the assertions, and outputs are always checked in assertions strong if it's outside proper range. So first of all, need to actually, first we need to check the method control simple exception. So we put throws, and we say that we throw simple calculation exception. In this case, it won't make anything. It's because that's just empty method. Nothing may be wrong there. And so, we'll need to implement adding operation. So in this case, we validate input and output. So in this case, maybe I will create separate methods. Separate method which will actually do the validation for me. So I will then add same thing here, and here as well. Right, so this is done, and the key method here is to actually validate input and validate output. So first, when we validate input, we just need to check if values are correct. So in this case, I also need to use throws because I will throw the exception here, and here I will check. So I will just try catch again. I will use the assertion errors here. Assertion errors. And now I can check. So I have the operations here. And basically we can add the separate validation for each integer. Let me think. This is maybe let's So yeah, we need to catch assertion errors and run them in the assertion class. So what does it mean? It means that we will have the assertion error here. And yeah, then I will need to then check if everything is correct or not. So that's it. So then I need to check if A is greater than 10. Oh yeah, maybe let's just fulfill all to do. So that is done. Validate inputs, yeah. Okay, using following, using following messages, so we need to add the description. So we're confused about it. Yeah, we need to add descriptions. So if values are not arranged, then we should provide the corresponding input. So for this purpose, I will maybe use different method. So I will call it this will be the one which returns string. So validate element. And the element. And here I can check. So if element is less than -10, then we return that A is is below -10. Else if A is greater than 10, then we return that A is about 8, is about 10. Or else we say that everything is fine. So, right here I can validate the error message we have. So that will be, let's say, error element 1. Maybe I'll say validation. And here I can validate first element. And the same I can do with the second element. So and then I can really check. So if then we need to do the assertions. Yeah. So first of all, if so actually I can check. Yeah, first we need to validate A and then validate B. Oh, okay. Yeah, in the following way. So if validation element first one is not empty, so since here we hardcode, we do not do any concatenation for this field, we can actually use this type of check, because again we don't do any concatenation. In this case, everything up to here. Yeah. We just provide hardcode value, so we can simply use comparison on here, and then validation element 2 also not equals. So in this case, we say that actually we can also use the assertion in this case. Maybe let's keep this option then. Also show how we can shorten this as well. Yeah, and in this case we say that input value A is below -10 and B is below 10. Okay. So this is this three values in here. So I say input value A, and output is this is the first validation element, and that should be that here. And then we can do the assertion. So remember, assertion fails when it is false. So after the assert statement, we provide an expression which returns true or false. So if it's false, then assertion error is triggered. So and in this case, I will also check. Sorry, not just too much. Here. So and here I need to check both elements. So I check with the first element. It's not false. It's not empty. Then if it's empty, I provide the also here also the same for the value B. And value B. Right. So and here we need to provide parts of these values. So and the same here is the second element. So in this case, one of these will be triggered because if they both are false, then this will be triggered. So done, and right here we need to provide the assertion error. So in this case, what I do, I simply create. Remember to draw the exception, we need to create a new object. Let's say that assertion error, and also need to provide the error here. To implement it, I need to use the constructor. Yes, and use the constructor. So, and in this case, I can provide, because by default I need to provide, I can provide two elements. So in this case, I need to write the constructor, and the second one will be throwable. Remember that the exception is the subclass of throwable class. And here I can simply call the superclass and write these two parameters. So now it should be fine. Also, we should keep the simple exception, otherwise this may be, this will not work if you just have one parameter instead of two parameters here. And so now this will work correctly. And so this is for the input. Now we can actually use this to validate it. And so we can do it. So I say validate input for both elements. and we basically built in all the classes. Plus all the methods. So we have 4 methods. So we can do it. So then the next one is validate output. We can actually place it under the return. So in this case, it's over here again, and as you can see, it returns the integer number. So, and it also should control the exception class, a simple exception class. So this is done, and we can actually have the result here. So here we need to again check the range, but firstly, of course, we need to do the operation. So I have the switch statement, and the operation is this one. Again, in this case, we can. Please be careful when you use switch for the strings, but yeah, for the switch, it should usually work wrong, but yeah, we need to be careful in such case. But okay, so not switch, the switch operation first. And let's go through values. So we have the value plus, and in this case, the result will be a plus b, and then we need to do the same for other cases. So that's for minus, and for the multiplication, and for the division. And yeah, for the division, as well, we need to check division by 0. So that's the arithmetic exception. So we can go to try, and we can go to catch. In this case, we should also call the exception, so that would be remember arithmetic exception. And we should. So you can also catch exception. In this case, you may not have any other exception, but the arithmetic exception. So in this case, it doesn't matter if you use arithmetic exception or just a simple exception clause. So then here the simple calculation, we need to provide information that that's division by 0. Of course, it's not allowed. Oh, sorry, that's exception, of course. It doesn't matter what kind of domain you use for the variable, as this is multiple. The only important thing, and the only important thing for the variables is the type of them and the sequence. All the other parameters are not needed. All the other parameters do not affect anything. Okay, so now we have try catch, and we need to check the result. So if the result is less than -10, then we throw the exception in simple calculation exception, and we say that output value, I'll just copy paste this logic from here, say that the output value, so here we should have the output value provided, so that's the so that should be the output value of A, then we have of course the operator, and this should be the operator operation. Then we have the B, so basically here it will be just simple A plus B or A divided by B. So it's this one. And have equals. So the result will be here. And we'll say that this is about this is about 10, so the same, but semicolon again. Okay, then the same for else if result is greater than 10, then have something similar. This case is the same, just result is of course here we have a ball and here we have the row. Row has of course. So this is done, and please note that the returning statement will be executed if no exception occurred. If the exception is occurred, then the result will not be returned. So, and let's execute it. So I guess that's it, right? Okay, if we missed something, then we can correct it. Something might be wrong. Let's check. Okay, we have. Okay. Oh, of course. I forgot to use this method. This method inside the method, suppose. So yeah, here we need to basically validate output. Actually, I don't really like such name of the method because, as I told you once, when we are in real world, then the best approach to name the methods is to actually find the name for the method which describes the method fully. Like if this is exception, it means that maybe something went wrong, and this is not what should let's say happen in the usual case. So in this case, from my point of view, the better name for the method will be getResult or something like that, because here we actually get the result. Of course, that's maybe, it depends on how you like to write the code, but basically, as I was taught, I was not young, but at the beginning of my programming work, then yeah, I was told to write the methods that name of the methods require. The methods mean the names which describe what your logic does in the best way. And like in this case, we not simply call the methods to validate the output, but actually to get the result. But okay, that's after the definition of the program. In this case, we are asked to do it this way. But yeah, maybe if you select, then I recommend to use something which actually describes the name of the method fully, or which describes the behavior of the method fully. So let's run the unit test, and let's check this. Okay, everything is right except the subtract. The result is not correct. Okay, let's. Okay, here was the errors, right? Subtract, I accidentally added the division, not the plus. Sorry, yeah, not the minus. Sorry, that was my fault. Let's check now. Okay, now everything's fine. So basically nothing complicated here, just a simple just a simple function of the assertions and assertion handling. Yeah, I said maybe we can maybe simplify this one. So as you remember, we have the set false, and then it means that this section should be say no. So you can actually put this section under the brackets, and as you remember, to get the opposite result of true, we actually need to use not sign, and this will actually should work the same way. Yeah, the same way. So basically, it actually works. Assertion means the same. If you have a statement which is true and you put assert false, then it is the same if you just simply put the opposite statement of the opposite result of the assertion. All right, so that's it about this one. Okay, thanks. Yeah, okay. So if you have any questions, then please ask, and we can move to the presentation about Git repositories, about version control. So basically, fortunately, I'll say in this course we actively use Git. So we actually started using Git since basically the first lesson in the first course we had. So it's pretty good. So we have already, let's say, half a year of experience, more than half a year experience working with Git, with version control. We actively use it, so it's really nice tool, and it will definitely always help you in real projects. Yeah, if it's your personal projects or the project in teams, then in all such areas, it's always better to use the version control to basically control your projects, to control the changes in your project, to follow them, to track them, and sometimes you may need also to roll back your changes if something goes wrong. And also you can document the changes this way. Actually you have all the tracking, so you can easily, if you, let's say you have the task to do something, so then you actually implement this task in just any environment, you use Git. Then once the task is done, so everything is done, you can just basically, after some time, when maybe you can share, you need to share what you've done, because maybe that's mostly about project work. We'll speak in the next topic, but version control is quite closely related to the actual project work, to the documentation, so it may really help in the project work. And when we actually have the working in team, so at the end of this course, then you will also use the version control, and you'll also use the approaches preferred under the project course. But okay, let's maybe start the agenda for version control. We will again, we already used Git a lot in our course, so most of the things will be quite familiar for you. That's really good. In this topic we will what I want to mostly include is so there are the branches. We previously did not use the branches, but I will show you what are the branches, how we can use them, and what's based on them. And then also talk about version control, also general. This is an empty slide. So basically, why do we need to have version control? So first again, that's related to the project work. So basically, if I say the project, it means that there are usually lots of people working on the same stuff or similar stuff, and then they need to share their code. They need to do changes. Then maybe something also go back to the changes. Then maybe sometimes also to merge the changes. And of course, it's not as easy to just simply share the code in that can be the notepad or just email or something like that. And just of course that's not how we should normally proceed. It's better to have one simple tracking system which will actually handle these things. In addition, again, if we go a little bit ahead and start talking about project work, since again, from my point of view, the version control and the organization of the project work are two quite related topics, closely related topics, and in both of these areas, I mean version control and project work, we should have the system which can collect, but to connect all the units of the units are these are the members of the project who actually work with on the project. So, and when we talk about version control, that's most related to one simple application where we have the application. The application can be a website. Basically, it can be whatever it can be. It can also be just something not related to programming. Why not? You can just simply initialize the repository, then just share maybe I don't know, any files you can share there. So it's not only about the code, but you can actually share whatever you want there. That's there's no any restrictions if this is the code, if this is related to programming or not. It can be whatever you want. But mostly we talk about some programs, some applications, and of course this is the way we can actually have version control. So basically, again, what's the first point? The first point is that let's say you have 4 developers. They work, again, in this case, it doesn't matter if they work from different countries. They can also work from different computers. The idea is that, especially now during the COVID times, maybe for us, it doesn't matter if we work alongside with the person from Germany, US, France, Italy, or just simply also from the person from Latvia. It doesn't matter all the countries. It depends on basically the multiple computers used, and the code is written in different places. So, and the idea is basically what happens when you have one application. And let's imagine that you don't have version control. You just have, let's say, it can be located globally. on the server, and then just everyone directly changes the server. So of course there can be really good communication established between the members of the project, so everyone really knows what he or she is doing, but then, as you may understand, it's not possible to achieve 100% communication with where all the members are involved, and that's why, of course, there must be something in between the actual application and the programmers or persons who work on this application. So basically, it means that before any changes are done, there is the place where the changes go through. Changes from everyone, and then there may be some checks here, can be done by another person, for example, and then only after that, after everything is checked, and we are sure that all the changes from everyone deployed correctly, they can be merged or just collected and applied to the application. Yeah, so basically what version install? First, that's mostly about when we need to develop non-trivial applications. Also, maybe one point from me, from my experience, in this case it's not only about if there are, let's say, 4 or more or less persons, more than one person, working on the same application. It may also be important when there's only one person working on the application. That's from my experience. You may also need to use assertions only if you're working alone on the application. And I will later explain why it's not only about merging the changes from multiple members. It can also be useful when there's just one person working. But again, the idea is that it is needed when you need to develop non-trivial applications. Again, if it's just one or two classes or simple methods, then of course in such cases maybe there's not much need. But if you work on the huge application and you work for many weeks or months or maybe even years, then of course it's needed to track the changes, because again no one of us is genius in the way that we can write the code to 100% correct without any issues with the knowledge what will happen in 1 or 2 years, for example. And of course, sometimes we need to go back and reverse if something is wrong. That's about backups and revisions, of course, if I say. Because you may understand that we may need to have backups. And if something is accidentally maybe changed or deleted, then if we have version control, then we can simply take a look back and find, maybe also retrieve the previous version if needed, and then move on with new changes there. Also information here if more than one person working in the same file. In this case, that's about the merging of the changes. We may need to talk a little later about it. Then we can move in time the versions, and also so-called parallel inversion. This is what what we have not really used before. These are the branches. The branches, and we will talk about them a little bit later. But the idea is that you may have, let's say, that's simply if you imagine that you and maybe your friend, you both go to the same target, but using to the same place, but using two different routes. So let's imagine that you both go to one place, but you use different routes. And in this case, at the end, you both achieve the same place, the same target, but you use different roads, different routes. And in such case, the same as in programming. You both you both work on the same, let's say, it can be the same change, the same fix, or same enhancement. So you have the changes on your files. So it means that you have separate branches. You both work on two different, can be two or more, but at this point that's mainly enough that you work on two different, using two different paths. So it means that your changes will not be intersected. Yeah. And you both work on your changes, and when you deploy the changes, then also when you push the changes, then your changes will not be mixed. Yeah. So it means that you work on two parallel branches, and at the end, we usually, to get the final version, we merge the branches. But yeah, we'll talk about them. So let's now move to the version control systems. You are currently all familiar with Git, but in general, again, the idea may be the types of, there are multiple types of the version controls used. And basically, in general, what the version control systems are. So let's see as the functionality is that file versions, that there's the file version control and divisions. We can use the tags and the branches, and you can check the differences and the merges of the branches and also of the files as well. For the what kind of versions we can use? Basically, yeah, we are all familiar now with Git, but yeah, there's also one additional source, which is Subversion. That's also free open source, and centralized version. We use Git, which is also free and open, but it's not centralized. It's centralized, it's distributed. Yeah, we can use both of them, and maybe not to use, that's the CVS. That's quite it's also free, but and open source centralized, but that's quite old version, and there are closed products like ClearCase, Helix, Microsoft EC. So these are all, maybe you can skip checking them. You mostly use Git, but maybe enough. There's again Subversion. We'll take a look on the overall idea of Subversion. Yeah, that's a little bit, has a little bit different structure. So basically, what are the words we use when we talk about Git? Because again, the idea for Git is good that Git is basically used everywhere. You can work using with Git Eclipse, basically all the IDEs. It's Eclipse, IntelliJ, Visual Studio Code, on everything. You can use all the possible IDs, and you will find the tools how to work with Git. So basically the approaches used are the same everywhere. You can also keep using the Git tools on the IDEs and just simply use the console. So if you have Git installed on your computer, for you I think that should be installed for everyone, since you are able to use it on your computer. And if you have Git bash, then it also means that Git is installed. And then you can just simply use the console and execute Git commands. They are the same for all the computers, for all the systems, so it's quite good. And of course they all use the same syntax and the same concept. So first of all, what are the terms used for Git? First of all, that's the repository. Repository is basically the place where the files are located. We have free repository. It depends. Yeah, in Git we have free levels of the repositories, but in different version control systems we may have different concepts of the repository. So maybe I will not say that they're always the same number of the repositories, but it can be different. It's just a place where the files are located, and basically the thing we can surely say that it can be stored on your computer, and it can also be stored on the centralized system, like Bitbucket, GitHub, or any other place. Yeah, then you have the origin and the version. That's actually the state of the file. That's the result of multiple changes. And the document file, then the same. Then you have checkout and clone. Checkout means that so we just simply finish the changes, and clone, that's when we actually have the remote repository, and then we just simply download it and copy. So it's something similar. Then we have the clone of the objects in Java. So that's quite similar. You just copy the repository and you use it as a new repository. And yeah, it's also possible to load the file, so it means that when the file is locked, it means that the changes will not be allowed until the previous changes are deployed. So that's maybe quite useful if you have the repository, it's usually a multi-repository, and then you have the set of changes to be done. So you mostly work, let's say, on maybe some files, let's say 5 files. Then you work on these 5 files, and to not so until you're done these changes, you don't want other members access these files, not access, but to change these files. So until you finish your changes. So basically means that you just log, let's say, all these 5 files you're working with, and once you are working with them, no one is allowed to change them. Yeah, also it's quite important. Loggings may also be quite important because of the sequence of the changes. Like let's say that that there's one file, then let's see, I will try to paint it. So let's say that you have a file. Let's maybe this circle. This is for the square. So let's say that you have the file, then you both work on the same file. Okay, so there's one person, there's another person. So let's say that you have, so this is the, so they both work on the same local repositories. So that's the repository which belongs to this person, and this is the repository which belongs to this person, and this is the remote repository. So let's say that they both work on the same file. So let's say that this is the person who started first. So the person just simply pulls the changes from here. The person pulls changes from here, and then he or she starts working on the file. So some changes are done, and during this period, this person also takes the changes from the remote repository. So basically, now they both are working on the same file, now they're both working on the same file, but the version of the file is also the same. They simply download it from the remote repository, and basically what happens, let's say that this one finished the changes first, so it deploys the changes. So there's the current version of the changes deployed by this person. But after that, this one also pushes the changes. So if we work with Git, then we may be talking about the merging. In other version control systems, it is possible then you'll face the situation when this person just overrides the changes from this person. So that's why the locking is needed, because we may have a situation, let's say you have this person may also work on 5 files, and then let's say that the changes from 4 files are correct at this place and at this point, and one of 5 files will be taken from this person, from this repository, and then at the end, again, as I said, you will have 4 correct files and 1 incorrect file. And what does it mean? It means that, let's say that if you have some very important logic, that's the program code, and you have very important logic on the file edited by initially taken from the repository, so that's the wrong file. And there can also be the classes, and at the end you may face the syntax error in the classes which are written correctly. Yeah, so basically you may have syntax errors just because this 5th file is not deployed correctly, and this may be the mistake. But again, in Git we mostly use merging, so before we push changes, all these things should be checked. But again, in other there are some types of version control where you will actually where you may have such issue. That's why this may be quite important. The change, so you change the file, so that's simple. How the changes are tracked. Yeah, so it means that once you're doing the changes, you may check what are the changes done by you. So you can compare the original version and the version written by you, and you can simply check all all the changes done. What's modified, what's not modified, and so on. So this is where you can check the revision, change set, simple change, a set of changes to multiple files that are going to be committed at the same time. So that's the staging, staging of the files. So if you can also skip pushing the file into the change set. In this case, once you do the commit, the changes will not be moved to the multiple after the push. Basically, they will not be tracked during the commit. And the commit itself, it basically that's the stage of the changes when you can actually put all the files you want to commit, and so again, this is the set of files committed. You may have more than one commit before you actually push the changes to your remote repository, and then you can simply collect all the commits. Then they will be moved to the local repository. Again, they will be moved to the local repository, and after that you can do the push and move all the changes to the remote repository. It automatically creates the version, so once the commit is done, then the version is created. And you may have conflicts when there are multiple comments on the same file. So we have, let's finish with these two slides, and then we'll go to, let's have the break now, and then we'll continue after the break. Okay? Okay, let's move on with the terms. So yeah, we may have the conflicts. So it means that we have the changes on the same file from two different sources. For users in theory, you can also have conflict when you working along as well. It basically means that you merge changes from two. Yeah, that's also from two branches, or also from two commits, and they are not they are mostly from different branches, and then you may have that they are tracked just on their path, and then you will have the conflict. And basically means that from two different sources you will have the conflict that changes. And yeah, this was called conflict. Then you have the update, the latest version, fetch, and pull. And basically all these operations help you to get the recent changes from the multi-repository to multi-repository, and yeah, also can merge files after that. You can also revert changes. Means that you simply cancel the local changes, and then you get you simply go back to the previous version again. Yeah, then you have merge, which basically means that you are merging changes from different sources. Drone is barking. Okay, let you know. Yeah, basically combine them locally, and then just simply merge all of them and also changes from them into one source. That's local repository. So you simply what you do, you fetch the files from the remote repository to the local repository, then you merge with the current files. And yeah, it's mostly can be automated. The labels just to mark the group of files. Labels syntax just to mark the files with the name to distinguish them from other files. And the last one is the branching. This is what I already mentioned. So basically the work walls for your work, and at the end you can just simply merge the branches. So basically what are the difference between tag and branches? It's simple. For the tags, it's you just have your changes with one specific characteristic, one or multiple characteristics. And the branch, which basically means that you have just different flows of your program. So let's start with the branching. That allows you to split the development into separate lifetimes, and that's also mentioned parallel universes. So it means that different developers work on different branches. Every one of them creates their own branch. Her own branch. Then do the changes there, and after the changes are done, and they mostly should be merged in one general branch, and then the changes will move further. Where it's needed, when there's development of finished feature, and that can be the feature where multiple persons work on them, then on the feature, then they need to proceed with different development, and they should combine their changes together. And also fix maybe there's need to fix bug in older version of the product while developing new unstable version of it. So basically just work on different workflows which do not interfere during the development process. Right, so that's about it. So when the feature implementation about is completed, then we set to merge changes at the end into one final merge. So let's now talk about the types of the version controls we have. So set the first, maybe the most simple version is centralized version control. So that means we have the server where our general repository is located, and then we have the local copies of it. So what we basically do, we commit the changes and update, commit, update, and so on. So nothing specific is done. We just simply can fetch the changes from our workstations and to our workstations, and then update them to the actual repository. So nothing in between, just the working copies and server, and one of the implementation is the subversion. So that's the thing of the central version system. There's open source, as I already mentioned. It's file orientated, and that can be used. So basically comparing, we can install it. So start using Linux, using Linux, which is simply one command for Windows. You can go to also to Git, and then install it. We will not work with it. We will, basically some basic commands. Again, it works similar to Git. You have index. Again, all the changes should be indexed, should be tracked before you actually move them to the remote repository. So that's basically a more simple version of Git. And the only difference is that we do not have something in the middle. So it actually means that you add the way to move change from the local workspace, you index these changes, then you commit, and your changes are now on the remote repository. The same comments on the opposite side are for the fetch operation. Also the copy, and then we will get your changes. Update merge switch, and then you'll get your changes on the local workspace. And to revert, it actually means that you have index your files, and then you simply revert to the current version and go back to the previous one. Alright, so that's about it, and we already worked, and we will, in this course, we'll work with distributed version control systems. So in this case, that's more familiar to us, we have three stages. Okay, so the first stage is then we write something on our computer. It's using IDE. We type something, then we do the command and go to our local Git repository. So basically we have two repositories on our computer. So the first one is the repository we are working with. So that's a working repository where we do the changes. So then we need to have a local Git repository which actually tracks all the changes we have. And that's basically responsible for the version control. And the similar repository is the remote repository, which is available for everyone. Local Git repository is available only for you, but the remote repository is the one used for everyone. Yeah. And basically when we do changes on our local computers, then we index the files, then we move them to the local Git repository. Then this stage may be used to check if everything is fine, and we can move our changes then next to the server. If not, then we may do additional changes before we move to the remote server. So basically, this is the stage where we can actually check if something is wrong, where we can collect the changes from multiple branches, from multiple developments, and only after that, after we are sure that everything is fine, then we can move to the remote repository. The same is for the local working repository. Yeah, so we may need to be sure that so before we pull the changes, then we also should be sure that everything is fine at this point. If we can merge changes, if we can import and then merge changes, and update. If everything is fine, then we can actually update our local repository. And as I said, this is mostly about Git. So what we use, that's basically it's open source version, which also basically can use it everywhere. Just download and use. It's designed kind of from small to very large project with speed and efficiency. So basically you can use it on your local projects and also on the big projects. You can actually use it everywhere. It's content-oriented, so it's based on what you do. There are no sub-repositories. There's just one repository, one exact repository. You can also expect only part of its workspace, so because you can actually you can only crawl it. So it's just simply put it, and it's initially designed and run by Linux for Linux kernel development. Kernel development is the core of the Linux. Kernel means something on the core level of the operating system. You can already, I think, everyone can install. In Eclipse, we for different IDEs, as I said, we have all the IDEs. We have the tools which help us working with Git. So in sometimes we need to maybe install some additional tools, additional packages maybe as well. In Eclipse, this is called Edit tool. you are all familiar with this, I hope. So there's nothing new for you, but you can, as I said, you can also do everything on the console level, and without using any tools for the IDEs you use, and this may also be fine. There are some I'd say, some quite simple commands which may help you to work with Git. So basically, the first one is config. Before you start working with your project, before you start using Git, you need to add the username for the remote repository, and also the password. And only after that you will be able to work with Git repository. So also you will have Git under the repository, have Git config file that basically collects all the configuration you have. All the configuration you have, and so you can check it in all the Git projects you have. You will not have the password there for obvious reasons. Let's just say because of safety reasons. The password should be hidden or encoded somewhere, and should not be quite easy to access it very well. So there's the upstream, basically checking out your username. There's the helper. It's so important. You will need to have. You may have the upstream. So that's push the current branch to its upstream branch, and it's simple. It's like upstream, but if you used to push if the upstream branch's name is different from the local one, and the current, so that's where you push. The current pushes the current branch to a branch of the same name. So basically, when you execute push commands, then the string actually shows, basically, and these commands show how the push is executed. So basically, you have some commands. I recommend if you use Git, I recommend you to maybe memorize them because again, you always can use ID, but sometimes you may need to not use ID, just simply work with your local folders, and in such case you may need to work in console, and then you may need to execute these commands. But basically they're just few main commands to know. If you work with one branch, then you first need to add configure your name, username, and password. Then you should add you should initialize Git repository, that's Git init command. Then you should add origin of the remote repository, so that's Git add remote origin name, Git remote origin name. Then you should can simply write the start work, and then you may have git add. I use git add /a. That means that you stage all changes. Then I use git commit /message, and then type the message, and then git push. Then to fetch the files, you need to use git if you just simply, if you not use fetch and merge, then you just simply use git pull origin master, and that's basically, these are the main commands. And if you just simply work with git on the local level. But yeah, here there are all the commands. So we have the stash, which basically means that these are all the changes you have here. So you track them, go to index, and you commit the changes. Then the changes are moved to the local repository, and actually all the new changes will go over these changes. After that, all the changes are collected here, and you simply push them to the remote repository. Yeah, please be careful, because you should have, if you work on the same branch, then you should have the synchronized version of the change. That's why you may have some version issues. In such case, I recommend to use git pull. So you pull all the changes and then git, and after that you may should be fine if you then track your changes and so basically, what I want to say, if you're working on the same project with other persons, then the best way how to, and you just simply use one branch without using multiple branches, and the only idea of using Git for you is just to keep your work synchronized with other members of the project. Then what you should usually do, before you do any changes on your local repository, you just simply do git pull. Git pull, you just get the latest version of the changes. Then you do your own changes. Changes are done. You may also be interested of using git pull again, just to be sure that nothing new is updated after you start the development, and then after that track all your changes and do git push at the end. So basically these are the commands. Commit done, then push. On the opposite way, you can do git pull. It will get all the changes from the remote repository. If you do git fetch, then it moves the changes to the local repository, and after that you can do reset. This will be reset. Then merge. That will be the same. You simply use git pull, but merge is maybe more stable. If you just have something to check in between different branches, then you may be interested in using git merge in such case. Okay. Yeah. So what? And sometimes we may also need to use force, so-called force pull or force push. Then in such cases, it means that the versions usually are not synchronized, and so if you have nothing, if there is no way you can correct your change or fix your issues, then you may need to use force push or force pull. It means that all the version changes, all the synchronization will be skipped, and you will actually have the new synchronized version of the changes. And here we have the main commands. Git init means you initialize your local repository. Then you have git bear in it. That creates remote repository and server. I usually just do it I usually use just Bitbucket and create the repository there, but it's also possible to visualize the repository using the console, but yeah, I prefer to do it just manually on the server. Git clone means you clone the remote repository. Then, you just simply, you will have the same as git init, but you will already have the full repository downloaded, and you will simply copy it from the remote repository. Then you may have to use, then you use git pull to just simply pull changes from the remote repository. That's makes sense, yeah. We always git add just stages, changes, just index them. So the changes, you add them, and they will be tracked to the commit. And then you have git commit, use and to define that we have a message. Then the status shows the status of the local workspace. Git differences shows the differences between the workspace and the repository. So that's it shows what are the differences. Remote add actually under the file first, so you provide the file name and it shows them differences. Remote add as a new repository. You just need to do it once, so once the repository is initialized, you add remote and then you provide the name and URL to it. And the last one is to push the changes. So here is the name of the remote repository. So you find the name here, and then you define where you want to push. Because you may have, usually you have, if this is just one remote repository, then we call it the origin, and we can just simply provide the name here and the branch where we want to push. So I'm sure this example will work. Right now, I will show you the console a little bit later with just our old example. And so in this case what happens, we go to the folder, we clone the remote repository. We don't do git initializing of it because we actually clone the repository from here. Then we can check the status. It will basically have all the setup needed, and then you just simply add changes, then add the message, and then push changes there. So the next one is the branches. I will not show you the branching on the console. I will instead we will take a look on it in Eclipse. Basically, what are the branches? How do we define them? So in console we can define by using the branch and then the name of the branch. Then we can check out branch in workspace. So we basically do the changes and commit them. And after we check out to another branch and git the branch and wonder what happens after that. But I'll show you. This will be shown in Eclipse. So I will show you how to use the branches. But right now let's move to the conflicts. Basically, when conflicts may happen, it means that the same file is changed by. Usually it means that the same file is changed by several persons parallelly. So it can be the same. It usually is on the same branch. So basically, You can apply different formatting, for example, or just do something differently which cannot really be merged normally in one file. And they also can be done using the branches, and it means that the problem will be when the branches are merged. So in this case, it's not so important if it's the same branch or multiple branches, because at the end we'll have merging from two different sources, and it means that something is there is the conflict between the changes. So how to, again, it's not good when we have the conflict, and we usually try to avoid them. So first we do file dividing. It means that you should not work on the you can divide the file into different parts, so it means that one person works on one part and another works on another part. It can be splitting into different methods, so one developer implements one method and another developer implements different method. That's possible. Time dividing means that we should not work on the same file together at one time. We should split the time. Anyway, I use the same formatting rules because it's important. Again, I use Ctrl-Shift-F in accuracy reports. You should normally work the same way for everyone, but the formatting rules may be different in different IDEs, in different languages, in different environments you work. So sometimes it can be different, and of course it will produce different results. So you can use inverse merging tools. In centralized you can use diff command. Indeed, you can use diff. This will provide difference between the files. You can do it using other tools as well. How to deal with conflicts? There are some tricks. So you can just do the following steps: stash changes and point changes, and then restore your stashed changes. In this case, I think maybe that won't be the best option. You can create local branch and merge into branch into master. This may be a little bit better. It means that you just simply collect into one branch, then correct the changes manually. That can be fine if you correct the changes manually, so you can control them. You can check where the issue is, what's wrong, and then provide the best solution to it. So if you have the conflict, then you'll have such signs in your file, and it means that something is wrong. You have the merging conflict there. The better approach is so you can configure and build other configurations. We will not build the configurations there. Graphical configuration will just simply keep what we have. So there is string, so explains that this is it. It tracks all collaborative work on projects with default distributed graph theory model. Then other says cool, how you use it. Says how you just memorize these short comments and then tab into sync all. If you get error, save your work. Elsewhere, delete the project and download download a fresh copy. This may be true, but yeah, from my experience, I usually also memorize the commands, and it simply works in the way that I have one project, one branch there. Before I start working, I do the command git pull origin master. Then I get the newest version, I do the changes, I git add /a, all the changes are staged, then I do git commits, then /m I apply the message, and then push the changes to the remote repository. This is usually works, but yeah, if the conflict appeared, you can create copies of the copy of the project. Actually, it's not always needed. Since you have all the versions, you can simply check the versions there. But yeah, you may need to correct the changes. Then actually check what are the conflicting files you have. Maybe you don't need one of them. You can just simply keep the one you need. Then you may check out using different comments. You can also maybe using different branches. Then merge them into one and actually correct the issues you have. Okay, you may use some comparison tools. Now to diffuse, and then you can apply differences in comparison tool manually, and then as you find all conflicting comments to the main project you have. Then you may also need to revert changes. So you need to fetch from the origin, that's the remote repository. And then we can reset, also called hard reset, all the changes, then clean, and then pull everything again. So in this case, that's hard reset, and you get all the changes. So for comparison, in Eclipse we have such option under edit. We can I have some changes slash here, so for the staging. We can open it here, and it compares the previous version of the file. So maybe what's working out today. So let's check, and here we'll see what are the changes done, and all the changes are highlighted, and we can just simply see what is changed, what is added, and what's not touched here. So you can also use other tools. And then the last thing is also where to place your changes and which remote repository to use. So there are some free versions, like GitHub. Maybe that's the most popular one. Yeah, that's the number one project hosting site in the world. Also, you may find some, if you have some open source, if you want to check some open source development, so it means that this is the development, the files, the program, the source code of the program, open source code of the program, then it is most likely that it is located on GitHub. So if you check some open source programs, then you may find them. They usually stored on GitHub, so it means that you navigate to GitHub, you have the link of the project you're looking for, and then just simply clone the repository or download it from there and use it on your computer. Yeah, it's free. You can use it without any restrictions. And then there's also GitLab, also similar to GitHub. There's Bitbucket. We already use and we will use while I like Bitbucket because there's actually synchronized environment between Bitbucket, source tree, that's the ID, which is alternative to, can be used as alternative to Eclipse. Then also Jira. We will use Jira in our project management. So all these stuff, all these systems are synchronized, and not the systems, all these things are synchronized and can be used as one environment. Yeah. Also, SourceForge. It's all GitHub for all people. We'll use Bitbucket. So first of all, today I will show you two things. The first one, just to remind you that we can just simply use the console instead of edit. So let's say that we create the folder here. So just copy my folder. It doesn't matter what do we have here. And let's go to Bitbucket, and I will create the remote repository here. So I will, and again you see we'll use one of mine. Maybe just do it as this. That should be fine, and the repository name should be my folder. From the private repository, and I will not do 231, and I will create the repository. We'll create the repository, so now I have a repository. I can clone it. I can also just simply initialize the repository. I think I will better simply initialize the repository in my folder. So I use git bash. You can also use simple command line. There's actually no difference. Here maybe git bash looks a little bit more colorful, and this may highlight some things better than just a simple command line. So first of all, need to set up the username. So let's set username. So that will be default global username, and simply use my name. Surname. Then I need to set up the email. So in Bitbucket I use this one. So it will be config. Global user email. I use this one. So now I set the email. In this case, it will just use the default when you contact your repository. And in this case, I have my user and password already set. So in this case, maybe I will not need to provide them, but let's check. So first of all, I initialize git repository. So I use the command git init, and this will initialize the repository. I have git repository. So this is the local repository I have on my computer. So this is, if we go back to the schema. So this is this one. Right? So we have on the middle. So I initialize the repository. So we can also use git clone. In this case, that will be the same, but I prefer using this one because this will basically just here we can follow all the steps. So I initialize the repository, then I need to add the remote. So then I add git remote add origin and yeah. So this is the sequence string. Yeah, I usually may forget the sequence. But yeah, we should start with git remote and then add origin. Yeah, so the sequence is correct in this case, but yeah, sometimes you may need to double check because yeah, from my experience I may forget the sequence used here. So you need to be careful. Yeah, then here you need to provide the path to the remote repository. So in this case, the path, you can check it here. So here's the path to the remote repository. Yeah, sometimes Ctrl+C, Ctrl+V will not work. Okay, now I added the origin. Sometimes you may, in this point, you will be asked to provide username and password. So you may need to type it here. And yeah, if you think it, then just simply provide them and you will be fine. So now this repository is connected to the remote, and I can do any changes here. So let's say I can create text file. So text file. So this is the text file. Then I can maybe add some other files. Yeah, I'll just bring some files to this folder. Yes, one more time. Okay, let's see this one. So I have 3 files here. Then what I do, I basically the most simple way to proceed with it, I use git add a, and at this point I stage changes. So the changes are indexed here, and the next step is to commit. So then I do git commit message. So this is the commit. So it shows me all the files connected, and the last step is git push. Origin master. So I use the command git push, which actually points that change will be pushed. And origin, this is the name of the remote repository we provided here. So basically here we define the name of the repository. We can actually have another name. So here we can connect it to even more than one repository. And that should be fine. But yeah, usually we just simply use one repository. And master, this is the branch. Yeah, as I said, we have multiple branches, but master, this is the main branch. Yeah, so git push, that's the command, and then we have the parameters. First parameter, name of the remote repository, That's the original defined. And master name of the branch. So that's the commands. And the changes should be pushed. It's waiting. Nothing refused, everything is fine. We go to the remote repository. And we see that pages are here. So files are here. Everything is here. Yeah, so the same way if you have, let's say, another person is working on the same folder. Again, that's not mandatory to be the IT project. It can also be basically any shared project. Nowhere it's said that you need to track the code changes. It can be any changes you make. So in this case, let's say I want to get files from the remote repository. So basically, I can in theory simply so let's maybe have the remote. No, I can initialize the repository. Initializing the repository. Then I add with remote origin with remote origin and then the path. The path is I usually miss the place where there's the path defined. I think that should be defined here. No moment. I usually use this place. Okay, maybe let's go. Okay, if we go Chrome, then we can check them. Can get the path here. We can actually just, without initializing, we can use the clone. Okay, maybe that's this one. So I'm gonna add remote repository. Oh, sorry, again the sequence is incorrect. Yeah, sorry, remote add again. I usually miss the sequence. So I'm now added, and I can simply use git full origin master. Sorry, misspelling. Git full origin master. Just misspelled here. And now I will have all the changes under my folder. So let's measure that took one person working on this folder and another person working on this folder. Can be on their own computers. So, and basically how I usually do, if something is done from this folder, let's say I do some changes here, then I index these changes, say file change, and then I git push the changes to the master branch. And before I do any changes here, again, the first approach to use is how I usually do. Before I do any changes, I need to do git origin master. And so repository is set, so now the changes are retrieved, and only after that I do my own changes. You can see that the file is updated. Right, so the task for you will be to simply create your repository and just repeat such steps. Again, this may be quite useful, so please just try it yourself and also create your repository. Just simply try to use console and type all these commands. Yeah. Again, this is quite useful, not if you work also not only with on IT projects, but just on IT projects, but maybe it's not about coding, it's not about using the IDEs, just some file sharing. You can simply use this in the console for such purpose. Alright, and the next step is I will show the branching and what does it mean. So for this one called some examples, we already have this. What does it mean? It means that, let's say that I will do two different tasks. So first what I do, I create, again, all the changes you do in the local repository, this is another world. Okay? You have three local workspace here where you actually do the coding. Again, you have three stages. The first, where you just write the code, then your local repository, and then the remote repository. So under your local repository, you do not have the Git, actually just have all these files here. And then these files actually can be controlled by local repository. And then you may have the branches. What does it mean? So first of all, let's say that we have two branches. What I will do, so I have switch, and I can create new branch. So what will be task 1, let's say. Switch to the branch, then you will have the task 1 branch. So what does it mean? It means that once you create it, again, you go to local, then you go to, then you right click and type to the branch. So now right click. So your repository, right click, switch to, and here you can create new branch. So what does it mean? It means that all the changes you do now, they will be tracked under task 1. So let's say I can create a new package. And that be task 1. Task 1. Then let's say I create some class here. Doesn't matter what kind of class I have, just one simple class. And then so let's say this is done. Stage. Should down these files while they are here. Okay, let's see. Okay, maybe let's just simply try this one. This file, I'll not use other files. I'm not sure where they are coming, but doesn't matter. So, test branch 1. Then I commit the changes, and now the changes are committed under this branch. Then I push. We don't have anything from the remote tracking. Then I push to the remote. Push to the remote. Maybe I can also not push, but in this case it doesn't matter. So I push to remote. I go to the remote repository. So let me check. Let me open it. So this one. Yeah, and here actually I have two branches. Right? so I have, so if we go to this one, I can see that nothing is updated from today under the master branch. But if we go to task 1, then we can see that all the files we done before, they are here. In addition, there is one more folder and one more file taken from this branch. Actually, we can also go to the so basically, if we go to the master branch, we will see that you can see that this file is not here, this folder is not here, and we can see that there's no such folder here. So basically, that's the parallel development. Now we have actually two branches. If we navigate to the branches, here we can actually see. Okay, there's no visualization here, unfortunately. Okay, maybe I think I see it in the bin bucket. Okay. Yeah, you can actually understand from here that. I think that's maybe not the best visualization for the comments. Okay, for the comments, I guess that may look better, but from my point of view, it still doesn't look. Okay, I'll show you how it looks in PHP Storm, which is similar to IntelliJ. I'm not sure why the branches look this way, but okay, I'll now show it how it looks like. Okay, it's really not visualized. But okay, I'll show you how the branches may be visualized. So if we open it, it's loading. Okay, so I can do this loading. It's almost done. Okay, so it's done now. There's the screen. Okay. So if we navigate to the, so we have to hit here, this section, and we may. I will show how to create in Bitbucket. Please know that it's a good question. How to create branches from Bitbucket? In Bitbucket, we not create anything in Bitbucket, because Bitbucket just replicates the changes we pushed from the local repositories. Okay, I'll show them later. But actually, usually the branches are visualized well. Regarding your question, in Bitbucket we do not create the branches. Again, everything what we see in Bitbucket we can create, but this is not what we usually do. We mostly do it from the. We should normally do it from the. We can create it, but again, the main idea is that we. As everything what we do it from Eclipse. I mean from the IDE. In Eclipse, what we do, we create the branches under our local repository. So if we create, we can also create it from Bitbucket, but again, the normal approach would be if we create it from the local repository and then push it the same as we do all the changes. We create them locally in our local repository, and then we push them into the remote repository. Same about the branches. Again, what happens? We go to the repository, to a local repository. This one, and that's our repository, which represents this one, this workspace we have here. Then we have branches section here. So here we have local, and here we have all the branches we have under our project. We press right click, we go to new branch, we create new branch. Here we provide the name of the branch, and then this branch will be here. So in this case I will, please be careful from where you check out. So in this case, if I check out from task 1, then this will be in another branch track from task 1. So in this case I will check out to master 1, and what does it mean? It means that, so in this case I go to master 1, I double click, and it means that I check out to master branch. And it means that all the changes I will see here will be the one tracked from the master branch. So again, as you can see here, we don't have the files under task 1. Yeah, we don't have the files. We check out to task 1, then we can see that the files here. If we check out to master branch, then again we are on the master branch. And so what happens? What happens? I can create the second task. Create the second task branch. So again, what do? I press on local, press new branch, and here I create the second branch. So here I'll create another task. So let's imagine that I'm working on 2 tasks now, and now I go from master branch to the task 2. So I'm over here, task 2, and let's say that I want to create a new folder. The package, and that will be task 2. So that's the package. I'll create, let's say, another file, task 2, and so this is the file, and this will be tracked under task 2. So now we have 2 branches. Again, they exist in parallel processes. Yeah, they do not interfere with each other. They all come from master branch. And now I stage the file here. I connect branch 2. I can just simply connect and push. And after that, push. And after that, the changes should appear here. So I have the branch here, so it will appear here. Yeah? So in Bitbucket, in the remote repository, it will appear after you push the changes. So basically, again, as I said, everything what comes from the local repository will be here. And we can see that here we have this task 2. We don't have task 1, but under task 1 we don't have task 2. And under the branch, under the master branch, we have nothing from both of the branches. And how we usually do in the end, so again, it's not visualized. We don't like. We should have a normal visualization. Oh yeah, okay. Here we have the visualization. Finally, we can see that. We go from the main branch to the two separate branches. Okay, and at the end, what we may do, we may go to we can check out to the master branch. Then we can press right click, and we can merge from different branches. So I will merge from the first branch. So I'm merging from the first branch. I can see that the file now appears under the master branch. The same is for the second task, so I press merge. I go to task 2. and now all the changes are here. So now I'm working on master branch. Yeah? So everything is now merged from both tasks. And in this case, I just simply press push, because I have nothing to commit, because all the commits were done under these two tasks, under these two branches. So I have no more changes to commit. And now if we go here, this one. And now if we go here, we can see that under the master branch we now have the first task and the second task. And if we go to branches here, not branches, let's go to commit. We can see that the changes are merged. Yeah, in this case, I'm not sure why it did not. Okay, in this case that can be fine. That should be fine. Yeah. So we actually have two branches, and then we just merge them into one. Yeah, and this is how it should normally be. We have a project to be, let's say, on the master branch. That's the main branch. And then we may have additional branches where we create a separate development, let's say task 1, task 2. Now after that both tasks are done, we merge them into the master branch, and then we have one branch on it. So the task for you is to test it yourself. So first of all, I will just simply type all the steps. So task for you, again, it's not before today, but also just before the next session. Just try it yourself. So first we create two separate branches, create one class in each of them, and then push them to the remote repository. So, and after that, merge them both to the master branch and push changes. Again, why we didn't add stage the changes, because basically we need to stage the changes before we commit. In this case, what actually happens, we actually merge two commits. We cannot, like if you do it this way, so you do something up. Let's check out. So let's say that you do something here. So define a method here. You stage it, but you do not commit. Then if you go here, the master branch, the change still remains unstaged. Remains unstaged. So it means that it will remain the same in all the branches. Yeah? So if you go check out this branch, the file is here. If you check to this branch, it will not work because you will need to have this file. You need to commit it before you move to another internal task, but if this file is located in both branches, then it will remain here before you commit. When you commit the changes, so let's say that you commit it under the task 1, so you stage, you commit changes in test file. After that, when you go here, it should disappear. The method should disappear, because we moved to different branch. So again, in this case, the main thing is controlled using commit. And when we switch between branches, then the commit is the changes from the commits are tracked. But we'll have more examples during the next session. For now, please try, if you have time today, or maybe also to do it tomorrow, or if you have time, just try it yourself. Create two separate branches, then create one class in each of them, and then move into the multi-repository, and then try to merge them. Okay, so try it yourself. If you have any questions, then as usual, please let me know. But for now, thank you very much for your attention today, and I'll meet you on Friday. Okay?